right, hey everybody. Great to be speaking at the Web3 Summit. Been coming here for a couple years, but first time speaking at this great venue, so it's good to be here. Yeah, like the introduction said, I'm Max Sherwood, co-founder of H2O Nodes. We're a node operator running validators on bare metal infrastructure on Ethereum, Solana, Sui, testnets like Monad, so focusing mostly on the high performance chains. Just some disclaimers or a little bit of context to understand kind of where I'm coming from. So at H2O Nodes, we've helped test both the SSV and OBOL software since 2022. I was pretty bullish on it initially, right after learning about it at DAppCon 2022, actually. So we've been involved for a while. I actually even worked at OBOL for 1.5 years, so might be a bit biased there. We're not investors in either project, but we did receive the OBOL airdrop, just disclaimer, and we continue to run both OBOL and SSV within Lido Simple DVT, which we'll talk about in a second. So for me to get a better sense of who I'm speaking to, has anyone ever run a node or a validator themselves? Oh, wow, fantastic, okay. Has anyone ever heard of distributed validator technology? Okay, cool, nice. So yeah, what I want to cover in this talk, why are distributed validators needed, what is a distributed validator, who are the distributed validator technology providers, how do DVs change the staking landscape. So why is distributed validator technology needed? If you're familiar with vanilla Ethereum staking, obviously to run one validator you need 32 ETH, which is quite a big hurdle for a lot of people, financially speaking, and you need a machine to run a node on. If the node goes down, your validator goes down, there's penalties for that. And the professional node operators have also quite a hard challenge to solve, which is basically how do you run thousands of validators, and if you're doing it the old-fashioned way, you just run many nodes and you put maybe 500, 1,000, 1,500 validators on each node. And if one of those nodes goes down, all those validators go down. So it's really not ideal. And for the liquid staking protocols, they are manually onboarding node operators. They have to sift through applications, figure out who is competent, who has good hardware, who has a good organizational setup. So it's quite cumbersome. So the problems, key management is risky. Even for the professionals, we've seen slashing at Bitcoin Suisse, Rocklogic, launch nodes, some of the professional node operators. Infstones had a security incident which caused them to have to rotate an entire set of keys, which doesn't lose your money, but loses you quite a lot of rewards. So, the prevailing wisdom is you should actually risk downtime. You shouldn't even try and run backups, because if you have the same validator key running in two places, that's how you get slashed on Ethereum. So instead of trying to build some active redundancy, you should actually just take the downtime penalty and not try and do anything too fancy. That's kind of been the prevailing wisdom. And downtime can happen easily, right? You can have an outage at your internet service provider. You can have an outage at the data center. You can have problems with a machine, like the disk filling up. Maybe you're doing too much logging, for example. Or there can be an Ethereum upgrade or a bug with a client, something that was out of your control that causes you to go down. And downtime is quite common, even for the professionals. So if you go on the Lido forums and you search incident or reimbursement, you get a number of results. Not to pick on the Lido node operators, but there is a good degree of transparency on those forums, so that's just why I've used these as an example. But these are a number of downtime incidents going back 2 or 3 years. These slides are also a little bit older, so I'm sure there's some more recent ones. But just to show you that everybody does suffer downtime. There's no such thing as 100% uptime, and everybody gets slashed sometimes as well. If you go to rated and you look at the entities running more than 5,000 keys, and the solo stakers, both of those entity classes have a pretty significant number of slashings that have occurred historically. So really, everybody gets slashed sometimes as well. It seems unavoidable. So with that context, what is a distributed validator? Think multi-sig, but for validators. So if you're familiar with a multi-sig wallet, instead of one private key being able to sign off on transactions by themselves, you can have a wallet that's controlled by multiple private keys, so maybe you need 2 out of 3 people to sign off on a transaction. Distributed validators are similar, so you need 2/3 threshold of key shares to do validator duties. So in this graphic, we've got 4 nodes. So you need 3 of those nodes to be online and active for the validator to be online and active. So one of those nodes can actually go offline, and the validator will stay online. And similar to a multi-sig, those nodes can be run by different parties, different people, and they can use different clients, and they can use different hardware. So, an issue with one client or one hardware stack doesn't necessarily mean an issue with the validators. So there's quite a good deal of robustness and redundancy that can be built in here without the risk of slashing. And that's because each node only has a key share. The nodes don't each have a full copy of the private key. They only have a key share, and if you need 3/4 of those key shares to be active, then you could duplicate one of those key shares somewhere, and it won't get you slashed immediately. So it significantly reduces the slashing risk as well. And this is really the first time you can have that 100% uptime without risking getting slashed. So who are the DVT providers? SSV currently has about 11% of network penetration, so that means that 11% of all staked ETH is being staked on SSV technology, or SSV validators. Obol has about 2% network penetration, and SafeStake is very small, so I won't talk about them beyond this slide. What are their approaches? If you're familiar with the Ethereum client stack, you've got a validator client, a consensus client, and an execution client. So the SSV approach here was to replace the validator client, which means that the SSV client is managing those key shares, communicating with the other clients in the other nodes in the cluster. SSV also went with a fee payer token design, so the token is called SSV, and you actually need SSV to pay 1% of your staking rewards as a fee. If you run out of SSV tokens, the validator stops running. And the key shares were created during a distributed key generation ceremony, DKG, and they're registered on-chain. So SSV is encrypting the keys, putting them on-chain, and the node operator's individual key is decrypting those to carry out the duties. So if we look at Obol by comparison, they've built a middleware, so they're slotting it in between the consensus client and the validator client. They're calling this more of an infrastructure agnostic solution, because you can run your existing validator client and you can just add the Obol middleware in there, so you can run it with your familiar validator clients. It likewise has a 1% fee, but it does not require a payment token. Everything's handled in ETH, and there's a solution called Obol Splits, which is a way for you to non-custodially direct the staking fee and the staking rewards to different parties. And the key shares likewise are created during a distributed key generation ceremony, but they remain local. They remain on the node, so they're not uploaded anywhere. If we look at performance, I think performance did struggle a bit in the early days, but now, this technology is now over 2 years old, so performance has gotten quite good. If we start on the top left with Lido Simple DVT, we'll talk about it a bit more in a second, but it's a bunch of different types of node operators running, so including amateur, semi-professional, professional, and they're currently in the top 45% of the network in terms of performance in the last 30 days, according to Rated. Which could be worse, could be better. SSV, if we look at them as an aggregate, they're in the top 30%. But if we look at the bottom two, so we've got EtherFi Obol and EtherFi SSV. Those are two clusters running on professional node operators only, and they're in the top 10% of the network by performance. So, if you do have professional operators running this, you can definitely score, in the top 10%. Otherwise, it's worth mentioning that a lot of the participants in Simple DVT, might not have been able to achieve this score if they had been running without DVT, right? So we'll talk about that more in a second, but generally I think performance gets the thumbs up. So how do DVs change the staking landscape? I think we should start with Lido Simple DVT, because they've really been at the forefront of boosting the adoption of distributed validators. Obviously Lido, in the early days had only 6 operators and generally scaled that up as they grew. I think now they have something like 36 in the curated set, but at the peak, there was almost 1% of the network being run on each operator, right? Because they had about a third of the network. They had 30, 35 operators, so the math's quite simple. And they got a lot of pressure because of that, right? A lot of people accusing them of being centralized. So they really leaned into DVT as a solution for this. They did a number of testnet waves. We participated in the final testnet wave. And then they onboarded over 323 unique operators across multiple clusters into Lido. So currently there's 36 OBL clusters, 36 SSV clusters. 5 more are designated as super clusters running each solution. So those are running, I think, 500 keys each. And yeah, I mean, they've managed to go from 30-something operators to 300-something operators using DVT. So pretty exciting. As we see in the pie chart, you know, the classification of these node operators, 39% of them, almost 40% of them are home stakers. Another third are professional node operators, 17% are community stakers, and almost 9% are from the curated set. So if you combine, you know, the home stakers and the community stakers, it's almost 2/3 of the simple DVT operators are, you know, amateur or community based, which is really good to see, because a lot of the Ethereum ethos has to do with running from home, you know, running as an individual. Currently, simple DVT is capped at 4% of Lido's stake, which doesn't sound like a lot, but that's actually currently over 9,600 validators that are active, which is about 308,000 ETH, and it's about 0.8 or almost 0.9% of the network. Currently, they haven't actually reached that 4% cap. They are, I think, around 3% of Lido's stake. The reason for that is that Lido didn't take stake away from the curated set and put it into simple DVT. They let the new inflows of stake come into simple DVT, and the outflows came out of the curated set. But there really wasn't a lot of growth in Lido over the past year since simple DVT launched, so they haven't hit that 4% cap yet. But yeah, this is probably, you know, the most significant implementation of DVT that we've seen from a liquid staking protocol so far. It's also worth mentioning EtherFi. So I think they're still the second biggest, largest liquid staking protocol on Ethereum. So they started with something called Operation Solo Staker quite a long time ago, I think almost 2 years ago now, where they onboarded solo stakers from 12 countries and 5 continents, and they've now got 1,120 validators running on DVs within Solo Staker. But then they also have professional DV clusters, which is over 12,000 validators running on OBL and SSV. I showed you the performance earlier. It's very good. So that's about 17.5% of EtherFi's stake is on DVs currently, so a much higher percentage than Lido, but obviously EtherFi is a bit smaller than Lido overall. But also, you know, definitely a good use of DVs to expand the node operator set, bring in solo stakers, and achieve good performance and resiliency. So when we talk about the effect on the network as a whole, right, what does it mean if the largest liquid staking protocols are using DVs to onboard tens or hundreds of new operators? Those operators will be running a mix of client types, a mix of hardware types, in a mix of geographies. And that effect is felt on the network as a whole, right? Because if there's a lot of stake running on DVs with a mix of clients and one client has a problem, it's no longer the case that all the validators running that client have a problem. The DV clusters can continue to function. So this is really going to boost the client diversity and the robustness of the entire Ethereum network. But we can also look beyond the Ethereum L1. So OBL's been... if you pay attention to their blog and their comms, they've been talking about other L1s like Polkadot or Monad. Actually, Polkadot, I think there was a discussion in the Polkadot forums about a year ago about DVs, whether those could be adopted. And yeah, the Monad announcement was from the OBL blog. So there's some stuff going on there where DVs could potentially be brought to other L1s beyond Ethereum. And SSV, if you look at their marketing, it has a lot to do with based applications, so using SSV to secure L2s and other types of networks on Ethereum as well. So pretty exciting time to see, you know, will this tech become not only the most commonly used way of securing the Ethereum L1, but also scaling beyond to other types of L1s. If we also think about the needs of institutions, if we can make staking safer for them, we can boost institutional participation in staking. Lower risks should hopefully mean staked ETFs one day. There's a number of reasons why institutions are kind of hesitant to stake, but I think slashing, and especially correlated slashing for them, is kind of a big boogeyman. So if we can reduce those risks with EVs, we can hopefully boost the institutional participation. There's something called NORS, which is the Node Operator Risk Standard from the Liquid Collective. Obol is a founding member of that. So that's, again, kind of a step in the institutional direction. And we're seeing institutional staking providers, so node operator companies, already leaning into DVT. So the other day there was an announcement from Obol regarding a partnership with Blockdaemon and Bitcoin Suisse, who are two of the largest node operators in the space. SSV has had pretty strong ties to P2P since the very beginning, and other companies as well. And even on the Lido forum, I think 2 or 3 weeks ago, they started discussing whether the curated set should be able to migrate their setups to DVT, which is going to be a pretty big deal because that set still controls 25% of the Ethereum stake. So we're definitely seeing adoption happen, but let's not forget about the home stakers who are able to use DVs to make staking more accessible. So they're able to pool stake with other operators, which means you can run a validator and contribute less than 32 ETH, which is a big hurdle, and you can achieve 100% uptime without slashing risk, right? Which was not really possible for home operators before this. So yeah, that was pretty much it. We'll leave time for questions, but in summary, vanilla staking is difficult. Distributed validators reduce risks. They perform well. Liquid staking protocols and operators are adopting distributed validators. Distributed validators strengthen the network, and they boost institutional and home staker participation. So big thumbs up there. But yeah, thank you for your attention. I'll leave plenty of time for questions. And yeah, this is our Twitter if you want to give us a follow. Thanks.